Overlapping triangles and coordinate proofs. Working with overlapping triangles. Overlapping triangles often share a common side or angle. When solving problems involving overlapping triangles, it may be helpful to separate and redraw the triangles. After separating, be sure to mark any givens on the triangles as well as any shared parts that would also be congruent. Here are some examples of separating overlapping triangles. You have triangle ACD here, triangle BCE here. By separating overlapping triangle this way, this one they share a same angle right here. So sometimes it is helpful to separate these two triangles and redraw like this here and here. And you can see I kind of like drew it again over, but they share same angle. ACD is congruent to ECB, the angle, and because they're reflexive. So if I go back to this slide, when solving problem involving overlapping triangles, which is this is overlapping, it is helpful to separate and redraw like what I did. I separate these red one to blue one, and then after separating, be sure to mark any given on the triangle as well as share part that will be congruent. So you just draw here. This is their overlapping. So this they share C and C, which is reflexive. Just mark them, okay? So we're going to do overlapping triangles proof. Here are two triangles. Triangle WZX, triangle XYW, and they're overlapping. They're on top of each other. So the given is angle ZXW, this angle is congruent to this angle, and then this angle is congruent to this angle. So they're congruent here. You want to prove that segment, the highlighted part here, side ZW is congruent to side YX. So you want to prove that this is congruent to this. So what you need to do is, it might be helpful to separate these two triangles. So draw this here, the left triangle here, the right triangle here. And then make a mark. So this angle and this angle is congruent. This angle is congruent, and they share a side. So what we're going to use is angle side angle. They share same angle, and same side. Those are congruent. So we're going to write that the given, and then we're going to write that WX equals WX. They share same side. That's reflexive because this is same side. And then we're going to say these two triangles are congruent because angle, side, angle. And then what we're going to say is the other corresponding parts. Side ZW is congruent to side YX because of CPCTC. Corresponding parts of corresponding triangles are congruent. So CPCTC. So after you prove the two triangles are congruent, when they're asking you to prove the other parts, other leftover corresponding parts, then we use CPCTC for our proof. Let's take a look at this one. This is also overlapping triangles proof. Given is triangle ACD is congruent to triangle BDC. So this triangle is congruent. So you can separate them and draw ACD, BDC separately here and mark where do they have in common. We want to prove this segment ACE is congruent to DE right here. So what we're going to write is given. These two triangles are congruent. That's given. And then we're going to say that this angle right here, ACD, ADC right here, this angle, is congruent to this angle. And we can use CPCTC because that is the extra angle right here. That is extra part, so we can use that corresponding angles are congruent. Once you know that if these two angles are congruent, we can say this and this is equal to each other, congruent to each other, because base angles theorem converse. Now, what is base angles theorem converse? I'm going to show you the previous lesson. So, previous lesson, we actually had, this is the slide from the previous unit, base angles theorem converse. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So right here, here is congruent. That means this side and this side is congruent. So if we go back to our proof right here, we can prove that this side and this side angles are congruent. Then this side is congruent. So when two angles are congruent and the side is congruent, we call this base angle theorem converse. So we need to write that and remember that for the proof. Let's take a look at the next proof. We have a overlapping triangle here. So the given is side PS is congruent to side RS. There's a mark right here. And then angle PSQ is congruent to RSQ. Write these two right here. We want to prove the triangle QPT is congruent to triangle QRT, the one on top right here. We want to prove that these two are congruent. So we're going to write the given. And then we're going to say QS, right here, QS is incongruent to QS. They are reflexive. Then we're going to say PSQ, the triangle PSQ, this triangle right here. And then RSQ, this right here, they are congruent because it's side, angle, side. So you have side, angle, side. And then we're going to say PQ, right here, PQ, and RQ, which is the other part of this big triangle right here. This is also congruent. You see this blue mark because of CPCTC. And then we're going to say that this angle and this angle is also congruent. PQT and RQT is also congruent. So with CPCTC, this side is congruent, this angle is congruent because we proved that this triangle is congruent to this triangle, the big ones. The left side and the right side, the whole thing. Once we have that, we can say that QT, right here, QT is equal to congruent to QT this side because it is reflexive. Then we got angle, side, angle, side. So this top triangle is congruent to this triangle because we have side, angle, side, angle, side. So we can actually use side, angle, side to prove that these two triangles are congruent. So whenever we prove two triangles are congruent, you gotta use the tools. Prove the triangles congruent using side, side, side. So you need to use the distance formula. So right here, you need to write down that this right here, the distance for this, 1, 2, 3, 4, 5, 6, 7 is congruent to here. This is the distance. So 7 and 7. And then right here you have 1, 2, 3, 4 and 4. You just have to prove this distance, hypotenuse, is congruent to this distance. So you need to use distance formula. You need to use this C point. You need to use A point. You need to use D point, E point as ordered pair and find the distance. So there's no given, there's no proof. So this one you just have to write down the measurement. You can also use Pythagorean theorem to solve that. You can use side, side, side to prove that these two triangles are congruent. You don't have to do the proof table. So I want you to do this one. Give me the measurement for each one. And I'm going to have you write that down and type your answers on Edpuzzle. You can actually use Pythagorean theorem, a squared plus b squared equals c squared, or you can use distance formula. So distance formula is this one. We just we learned that in unit 1. X squared minus x2 minus x1 square plus y2 minus y1 square. You can actually use that distance formula to find the hypotenuse, or you can do a squared plus b squared equals c squared. So I want you to do that and give me the length for this each side and prove that you can use SSS. And then this one also, I want you to find the length of each one and then prove that this one is congruent. So I want you to do that. So pause the video and do that, and you can type your answers into Edpuzzle video. Thank you for watching.